What's going on, guys? Let's look at this problem right here. Here this question is asking three impedances of value C delta is equal to 12 angle 39.6 degree are connected in delta for balanced line to line voltages of 208 voltage. Find line current and the total reactive power. What are the equivalent impedances for the same total reactive power if they are connected in Y? Okay, first we have to find out the reactive power, and after that we are going to find out the equivalent impedance for the same reactive power in the Y circuit. Okay, first we have given the delta circuit. Now let's go ahead and draw the delta circuit. The delta circuit will look like this. We will have impedances in the delta shape. Okay, and the voltage across this delta is given to be 208 voltage. 208 voltage right here, and the given impedance is in angle. We had to convert this one into real number and imaginary number. To convert that one, 12 39.6, and if we convert this one into real and imaginary, that's going to look like this. First we had to convert this one angle into real and imaginary. For that we put cos 39.6 for real number and j sine 39.6 for the imaginary value. And if you convert this one, this is going to become 9.25, that's real value, and the imaginary value is going to be j 7.65. so here the resistance is 9.25 and the impedance is j 7.65. okay, now the next thing is we are going to find out the phase current. I phase is similar to voltage, the basic law, V is equal to IR. Here V is equal to I times impedance, so I is equal to V is equal to IZ, therefore I is equal to V over Z. Voltage is 208 voltage and the impedance we calculated 9.25 plus j 7.65, and if you calculate the phase current, that's going to become 17.33 and the angle is negative 39.6 degree. Now the next thing is we are going to find out the load current. Load current is √3 times I phase, and that gives us approximately 30. okay, now here our purpose is to find out the reactive power, total reactive power. Total reactive power is Q is equal to 3 IRMS square. This is in phase. Phase means this is the current we are going to use, times the angle. In our case, we have to look at this impedance as the angle. Let's put Z right here. okay, then 3 times IRMS square is, we calculated the I phase, that's going to be the IRMS, that is 17.33 square times the impedance, that is only the imaginary part, that is j, here we don't have to put the j, 7.65. okay, and if you calculate this value, that's going to be 6892 kilowatt. This is our total reactive power. This is the first question. The first question is asking find line current and the total reactive power. We found out the line current to be 30 and the total reactive power to be 6892. Next thing is we have to find out the impedance for the equivalent impedance for the same total reactive power in the Y circuit. First let's go ahead and convert this circuit into Y. Okay, so to convert this one, first we have to convert the impedance. The given impedance, the initial impedance was 12 angle 39.6 degree. To convert this one into Y system, we have to divide this one by 3. So the new impedance for the Y system will become 12 angle 39.6 degree divided by 3, and that gives us 4 angle 39.6 degree. So this is going to be the angle for the delta system. Now Y system. Let's go ahead and separate this one. Here let's go ahead and draw the Y system. Y system is going to look like this. the shape will look like a Y upside down. Okay, here we found out our impedance to be 4 angle 39.6, and the voltage is 208 divided by root 3. Voltage across this Y system is 208. When we convert from delta to Y, we have to divide the voltage by root 3. And that's it. Now let's go ahead and calculate our purpose is to find the impedance, and we have to make sure we get the same reactive power in the same impedance, like in this 4.4 angle 39.6. Now to find out this one, first we had to calculate the I phase RMS. I phase RMS is voltage divided by the impedance. That is, let's keep this one, keep both of them in the angle, so it's easy to do that. So this is going to be 208 root 3 divided by root 3 divided by 4 angle 39.6, and that gives us negative 39.6, and this is our RMS current. Now from the previous one we know the equation for the reactive power, that is Q is equal to 3 IRMS square times the impedance, that is 3 times 30 square, 3 times 30 square times 4, that is the impedance, times the angle. For this angle we only consider the imaginary part, that's sine 39.6, and if you calculate this one you will get approximately 6890 kilowatt. And if you compare the total reactive power, it's similar to the previous one, so it means this is going to be the impedance for the same reactive power, 4 angle 39.6, and that's the answer for the second part. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electromechanical system, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.